Hey Course 2, it's Miss Bloodworth here, and I'm here to talk to you a little bit more about what we did in class today on adding and subtracting fractions. If at all you get a little bit confused, you can just check out the video I made yesterday. Anyway, what we built on today in class, this is the video for that today, September 11th. So let's go ahead and jump into this, and hopefully this helps clarify some things that you may have with your homework tonight. So it says sometimes when subtracting mixed numbers, we must regroup them. So I gave the example on your handout page for today about when we have a $1 bill. And I asked you guys, what are some different ways we can make a $1 bill with different types of change? You guys answered a lot of fun things like 3 quarters and 1 nickel and 2 dimes. Some of you said 10 dimes. Some of you said 2 quarters and 5 dimes. Some people said 4 quarters. There's a ton of different combinations of things that make $1, but they all look different, right? And so regrouping with fractions is kind of like making change with fractions, okay? And I listed this example at the bottom here where it says 1 equals 8/8, which I'll explain kind of in a second. 1 equals 5/5, and 2 equals 6/3. So if that kind of confuses you, don't worry. I'm going to explain that in just a moment. But what we know for sure with fractions is that any number over itself equals 1. So in the example I show right here on the screen, it shows 2 over 2 equals 1. Because if you look at this like a problem, it's actually saying 2 divided by 2 equals 1. Because any number divided by itself is 1, okay? And for those of you who are visual and who need to see that it actually makes up 1, I put the 2 divided by 2 over each other and then put the 1 around it. But that's only if that's helpful to you, okay? And so when we have these numbers over here that say, going back to that last slide, where it said 1 equals 8 over 8, I wanted to show this too. So where it says 8 over 8, right, equals 1, we know that because 8 divided by 8 equals 1, okay? The next example that we had over there was 1 equals 5/5. Well, we know that if I have 5 out of 5 of something, then it's going to be 1 whole of something, right? So if I have this graph over here, and I have 3 pieces on this side and 2 on that side, and I color all of those, or I put a dot on each one of those, that's 5 out of 5 dots. That's 1 whole that I have together, okay? So that's all I'm reiterating right there is pretty basic. 5 divided by 5 is 1, okay? But then we get into the kind of complicated one where most people start to struggle a little bit, is where they see 2 equals 6/3, okay? So when I write it out over here, I'm going to choose a different color. It says 6/3, right? So first of all, we know this is an improper fraction. So if we decide to fix it, 6 divided by 3, we're going to get 2, right? Which was our answer for that whole number, right? So when you're dividing, you want to make sure that your fraction is equal to what it says it's going to be equal. So I wouldn't say 2 equals 6 over 6. That would be incorrect because we know that 6 over 6 equals 1 because 6 divided by 6 is 1. So when we have 6 over 3, we know that 6 divided by 3 is 2. So that claim of 2 equals 6/3 is true. So yes, that's correct. It's a happy face. So hopefully that helps you understand that just a little bit as we continue forward. So let's take a look at this problem. First, this is a we do, so we try this one together. It says, what do you notice about these numbers? Take a second to think about it. You should have noticed that this 1 over here is a whole number, and the numbers on this side is actually a fraction. So we have 1 minus 2/7, okay? So if this problem kind of confuses you, just take a deep breath. Don't worry, I'm going to explain how to do it in just a second. But I want you to take a note of something. How do we subtract a whole number by a fraction? Okay, well, let's review our rules for subtracting fractions. We know that we cannot add or subtract fractions if the denominators are not the same. It's just a rule. That's why yesterday we spent a long time trying to find the least common multiple so that we're able to convert that fraction, rename it, and then continue on with our problem. Well, the same thing is true for when we're subtracting whole numbers by fractions. So I'll come over to my little pad here, and I'm going to show you. So we have this whole number 1 right here minus, I think it said 2/7. So we have to be able to make 1 into a fraction with the denominator of 7. Well, I mean, I know that we have to turn this into a fraction that's similar. So I'm going to convert it into 7 over 7 because I know that 1 or 7 divided by 7 is going to be 1. And I know that I have to get a matching denominator. And so I'm just going to bring this half straight back down. So 7 over 7 minus 2/7. And if I go all the way across at that, 7 minus 2 is 5. And in subtracting, we just keep that denominator the same. So I should end up with the fraction 5/7. Okay? So that example was a pretty easy one. What I want you to do is at home, I want you to try this next one that I'm giving you. This one's not on the worksheet that I handed out to you. This is just a practice problem, but I want you to try this either on a piece of paper or if you have a whiteboard or whatever the case may be. Practice 1 minus 3/4, and I'll go over that answer with you in just a moment. Okay, let's go over that answer. So when we look at 1 minus 3/4, we know that we have to get 1 into a denominator that's 4. So I converted 1 into 4 over 4, and then I subtracted 3/4 from it. So 4 minus 3 is 1. 4 minus 4 will stay 4. So our answer will be 1/4. Okay? And for those of you who are a little bit more visual, let me try drawing it for you this way. Okay, so when it says 1 minus 3/4, if I come over here to my little drawing and I'm trying to draw 1, I'm going to highlight or scribble on the ones that make up 1. So I know that 1 is 4 out of 4, because 4 out of 4 of these circles, when they're shaded, will convert to 1. Okay, so that's what I did here. So if I subtract 3/4 from it, I'm going to come back over with a different color, the blue, and I'm going to shade out 3/4 of that. So I'm just going to circle 1, 2, 3. Okay, so that's the minus 3/4 part. If I go back with a different color, I'm going to try pink this time, and I circle the only ones that doesn't have the blue in it, I notice that I have 1/4 of it left. So if it helps you a little bit to draw out those circles as you're trying this, I would encourage you to do that. However, I wouldn't become dependent on it because it's only for smaller numbers, and really the point of it is to get you to see how this number, 4/4, converts back into 1. Okay? So hopefully that helped you if that didn't make sense already. But I had a friend of mine ask me today, but what happens if your whole number isn't 1? What happens if it changes to something like 2? Well, that's what this next problem is all about. I'm going to show you what we do when our whole number isn't just 1, when it happens to change to a different number like 2 or 3 or 4 or 5, right? So what we do is we have to keep the same rules true, right? So we have, like I said earlier, we know that a fraction is kind of like a division problem. So we want to make sure that whatever we do, it's divisible by that number. For example, we know that 2 minus 3/10, we want to get our denominator on the left side to be 10. So if I come over here and I draw a 10 at the bottom, so if I draw that over here, the 10 at the bottom, and I have 3/10, so like I have to keep that minus 3/10 over here, and I still have to figure out what to do with the top. I have to figure out what number, if I divide a certain number by something, how it's going to get me the answer 2, right? So I know that if I divide 10 from 20, it's going to give me the answer 2. So that's how I end up with 20 on the top. I do 20 over 10 minus 3/10, so I just copy down exactly what was above, and then I subtract. So I should get 20 minus 3 is 17, and I have that over the number 10. But am I done here? The whole class usually answers no, because this is an improper fraction, and this is where a lot of our friends get kind of confused. This is where we have to divide so that we can get a mixed number for our answer. Well, we know that 10 goes into 17 once, and so we subtract 10 from 17, and then we get the remainder of 7. So our new answer will be 1 7/10 as our answer for this problem. So if you understand that, awesome. If that was a little bit hard for you, shoot me an email. I'll try to re-explain it as best as I possibly can. Hopefully that was able to help you just a tiny bit. Okay, so I want you to try this one on your own. It's your turn to try 5 minus 3/20. Pause the video, and when you're ready to see what the answer was, hit play and let's check that answer together. Okay, let's go over that answer. So 5 minus 3/20. Well, I know that if I put 20 on my denominator on this side, I know that 100 divided by 20 is going to give me that whole number 5 that I have up here, right? So I take 100 over 20, subtract 3 over 20, and I get 97 over 20. But that's an improper fraction, right? So I have to convert that fraction by dividing it into itself. So 97 divided by 20. I know it goes in 4 times, so I have 80 with the whole number 4, the remainder 17, and 20 at the bottom. So my answer for this one should be 4 17/20 as the answer. All right, this next part we're moving on, and we're combining regrouping with mixed numbers. So these two concepts we just talked about, we're going to collide into one world, okay? So here's the first problem I want to give you guys. We have 2 1/4 minus 3/4. Now this looks like it could be easy because when we look at these two denominators right here, we notice that they're the same, which means we should be able to subtract straight across, right? Wrong. In this case, it makes it a little bit difficult because we have 2 1/4 minus 3/4. Because if we look at those numerators, we notice that actually 1/4 is smaller than 3/4, right? So how in the world am I supposed to solve this? Well, if I come over to my sketch pad and I write out 2 1/4 minus 3/4, I know that I need to convert this mixed number into a fraction. So I did this thing called the heart. And if you learned it, some people learned it as a half circle. It's whatever is easiest for you. But hearts are fun for me, so that's what I'm going to stick to. So I'm going to change my color. I'm going to go 4 times 2. So I'm going to put my little multiplication sign right there, which I know is 8. Then I'm going to take 8 and I'm going to add 1 to it, where the top of my heart is, right? So 4 times 2 is 8. 8 plus 1 is 9. And then I'm going to come back around and put 9 over my circled's denominator. So now my new fraction is going to be, sorry, that was supposed to be an arrow. So it's going to be 9 over 4 for my new fraction on this side. And since we got it to an improper fraction here, we can actually just drop down whatever was on this side, which was the minus 3/4, okay? And now I can do my math straight across because those denominators are matching, right? So 9 minus 3, we know is 6, right? So we have 6 over 4. But this is still an improper fraction, right? So what do I have to do? That's right. I have to simplify it. And I do that by, I do that by coming over here and dividing it, right? So I have 4 and 6. I know that 4 goes into 6 one time. I know that I'll have a remainder of 2. So I'll have 1